Good morning, class. Orthographic projection shows accurate dimensions but requires engineering training to visualize the 3D object. Pictorial drawing shows the object in 3 dimensions, making it easy for non-engineers to understand. There are several types of pictorial drawing. Today we study isometric drawing, the most commonly used pictorial method in technical drawing. In isometric drawing, 3 edges of the object are drawn at 30 degrees to the horizontal, giving a realistic-looking 3D representation. WAEC technical drawing tests isometric drawing from given orthographic views. Isometric drawing is used in Nigeria for product catalogs, assembly instructions, and architectural presentations. Isometric drawing properties. 1. 3 principal axes, 1 vertical axis, and 2 axes at 30 degrees to the horizontal, 30 degrees left and 30 degrees right from the vertical. 2. True lengths. All lengths measured along or parallel to the 3 isometric axes are drawn true to scale, not foreshortened. This is the key feature of isometric drawing. 3. Lines not parallel to any isometric axis are called non-isometric lines. They must be located by plotting their endpoints using isometric coordinates, not measured directly. 4. There is no perspective, no vanishing point, parallel edges remain parallel on the drawing. Isometric scale. Technically, true isometric scale is approximately 82% of true size, to correct for the projection. However, in practice, and for WAEC, full isometric, using true dimensions, is accepted and expected. Full isometric makes construction faster. Setting up isometric axis. Vertical axis, straight up. Left axis, 30 degrees to the left of horizontal. Right axis, 30 degrees to the right of horizontal. All 3 axes meet at the front corner, lowest corner for a box, the origin point. Drawing a rectangular box in isometric. Given, object with length L, width W, height H. Step 1. Mark the front lower corner as the origin point O. Step 2. From O, draw the right edge along the 30 degrees right axis, length equals L. Step 3. From O, draw the left edge along the 30 degrees left axis, length equals W. Step 4. From O, draw the vertical edge straight up, length equals H. Step 5. Complete the box. From the top of the vertical edge, draw parallels to the L and W edges. From the ends of L and W edges, draw verticals. Step 6. Show visible edges as solid lines, show hidden edges as dashed lines, or omit hidden lines for clarity. Important, use a 30 to 60 degrees set square with the T-square to draw the 30 degrees axis precisely. The vertical is drawn with the T-square and a set square at 90 degrees. Step blocks. Many WAEC questions show a rectangular block with a notch or step. Break it down into simpler boxes or use the coordinate method. 1. Draw the full bounding box. 2. Remove the sections that are cut away, draw over them with the background color or leave them out. 3. Add the step edges. Nigerian application. Furniture designers in ABA, Kano, and Lagos use isometric sketches to present cabinet and shelf designs to clients before manufacturing. The 3D view is immediately understandable to a client who cannot read orthographic views. Circles in isometric projection appear as ellipses. Method. For center approximate ellipse, most common method for WAEC. Step 1. Draw the isometric square, rhombus, that would enclose the circle. For a circle on the top face, the rhombus has sides equals diameter, with 30 degrees axis. For a circle on the front face, the rhombus uses the vertical and 130 degrees axis. Step 2. Find the midpoints of all 4 sides of the rhombus. Step 3. From the 2 acute corners of the rhombus, the sharper corners, draw lines to the midpoints of the non-adjacent sides. These lines intersect to give the 4 centers. Step 4. Use a compass to draw 4 arcs. 2 large arcs centered at the acute corners of the rhombus. 2 small arcs centered at the intersection points inside the rhombus. Adjust radius so each arc starts and ends exactly at the midpoints of the sides. Step 5. The 4 arcs together form a smooth ellipse, a reasonable approximation of the true isometric circle. Cylinder in isometric. Step 1. Draw the top ellipse, circle face, using the 4-center method. Step 2. Drop vertical edges, parallel to vertical axis, of length equals height of cylinder. Step 3. Draw the bottom ellipse, use the same method, displaced downward by the height. Step 4. Only show the visible part of the bottom ellipse, with the back half is hidden. Step 5. Add tangent lines connecting the outer points of both ellipses. These are the silhouette lines of the cylinder. WAEC Technical Drawing Questions on Isometric Drawing. Question 1. State 2 characteristics of isometric drawing. Answer. 1. The 3 principal axes are 1 vertical and 2 are 30 degrees to the horizontal. 2. All dimensions parallel to the 3 axes are drawn at true length, not foreshortened. 3. There is no perspective, parallel edges remain parallel on the drawing. Any 2 of these. Question 2. Describe how an isometric box of dimensions 60 mm x 40 mm x 30 mm, L times W times H, would be drawn. Answer. 1. Mark origin point at front bottom corner. 2. Draw right axis at 30 degrees right, length 60 mm. 3. Draw left axis at 30 degrees left, length 40 mm. 4. Draw vertical axis straight up, 30 mm. 5. Complete the box by drawing parallels from each endpoint. From end of 60 mm edge, draw vertical 30 mm. From end of 40 mm edge, draw vertical 30 mm. Join top edges along 30 degrees axis to close the box. All edges parallel to the 3 axes. Question 3. Why do circles appear as ellipses in isometric drawing? Answer. In isometric drawing, all dimensions are plotted along 3 axes at specific angles, vertical and plus or minus 30 degrees. A circle, when viewed from an angle, rather than directly face-on, and plotted along these axes, produces an ellipse rather than a circle. The circle's diameter remains true in the 2 axis directions, but the curvature and proportions are distorted when plotted on the inclined axis, producing the elliptical shape. Question 4. What are non-isometric lines and how are they drawn? Answer. Non-isometric lines are edges of an object that are not parallel to any of the 3 isometric axes. They appear at angles other than vertical, 30 degree left, or 30 degree right on the drawing. They cannot be measured directly in isometric. To draw them, locate their endpoints using isometric coordinates, find where each endpoint is along the 3 axes, plot both endpoints, then connect them with a straight line. Question 5. What is the difference between a true isometric drawing and a full isometric drawing? Answer. True isometric uses a reduced scale of approximately 82% to compensate for the projection angle, giving a technically accurate representation. Full isometric, also called conventional isometric, uses the true dimensions directly on all 3 axes without reduction. For WAEC technical drawing, full isometric is used because it is faster and the question normally gives dimensions to be plotted directly. Both produce similar visual results. Isometric drawing bridges the gap between technical precision and visual communication. In Nigeria's growing engineering design and product development ecosystem, the ability to produce clear 3D isometric drawings is invaluable, whether presenting to clients, briefing factory workers, or documenting product assemblies. You now have the foundation to draw the world in 3 dimensions. Powered by Lightech Academy academy.lightech.com.ng NERDC-approved SS1 Technical Drawing.